So we are live. Hello, everyone. I hope that you're having a great time. Today, we are going to cover algorithmic trading with Python. We'll focus on a practical case to develop a machine learning model to predict what will happen tomorrow and to incorporate the machine learning model into an investment strategy to later backtest how good it could have been on past historical data. Let me give you some context about the work that we are doing every week. We are hosting weekly sessions. Today is the 5th one. You can see that the topics are all recorded in our YouTube channel. And if we also develop tutorials every week, as you can see here, Datons.py. The one we will base today's session is here. Backtesting with machine learning based investment strategies. The code is explained step by step, you can see. And during these sessions, I will get deeper onto the topic as well as interacting with my fellow participants here in the Zoom. And if you want to suggest new content, new tutorials that you would like to learn for your projects, feel free to do so in our collaborative roadmap, where you can see some people suggested in the past basic algorithmic trading with Python, and we have provided the live session and also the tutorials. The rules of these live sessions is you asking me all of the possible questions you want, because sometimes you may assume that you know some things, but then you are working in the projects by yourself and you feel you lose a lot of time while developing the code. So I want to help you think like the machine to program it faster and develop the solutions of your projects. They can be questions about anything. It doesn't have to be related to the challenge itself, but to programming, pre-processing, visualization, analysis, statistics, machine learning, AI. And they can be in many industries: finance, energy, medicine, however you'd like. Then if you are studying on your own and you want to learn how you should think the problems to program them faster, you can post the questions in our Reddit channel, where I will personally attend your questions. Now, today's challenge is basic algorithmic trading with Python. Problem is that many people have once fantasized with the idea of getting rich by investing in the stock market. Never happened. But putting real money on it is risky. So why don't we simulate investment strategies with Python to see how much money we would have earned or lost? And that's what we call backtesting an investment strategy. So the goal is to pre-process stock market data from the daily transactions that are performed to create investment strategies that will buy or sell a stock to simulate their performance using Python. We will take Apple stock or anyone that you want to suggest and evaluate an investment strategy over the last 5 years to see if it could fit the mathematical equation of the machine learning model for the future. Here you have some references to the libraries that we will use: Yahoo Finance, Pandas, and Backtesting.py, which is the library we will use to create both the investment strategy. As you can see here, they are making an investment strategy where they are selecting whether to buy or sell the stock. They simulate the backtesting strategy, And here they will see the report with the duration of the investment strategy, as well as other key metrics such as the return in percents or the final equity in dollars based on the initial amount that was $10,000. Here you can also get a visual report where you can see all the individual trades that have been performed over the simulation to see the details. So without further ado, let's get started with the Python code. Let's scripts. So, Viva, how do we download stock market data?
The Y Finance library.
Okay. To import it?
Import library. Yeah.
So we import, press the tab button to see the suggestion of all the libraries. We see Y Finance. We can have it as YF. And now we download the ticker from Apple that we need to search in Yahoo Finance for the codes. We would search here for Apple. And between the parentheses, we will see the ticker that we will use in the download function to get the historical daily transactions from the Apple stock in the market. Now, to work with the data, we save it into a variable. Let's call it df base, as it's the initial data frame we will work with. And now I want to predict what will be the price tomorrow with a machine learning model. So to import the machine learning model, Viva, what would we do? Yeah. Have you worked with machine learning before?
Which model are we talking about here?
For example, decision tree. Let's make it easy. If you remember, I want to help you think how to program it without looking at Google or anything else. Where are the models or the algorithms from machine learning in the Python code? In which library? If you remember.
Not sure.
Okay. Do you remember some letter like SK?
Oh, sklearn. Oh.
Yeah. Did you understand that or anything else?
Is that scikit?
Yeah, that's it.
Yeah.
Scikit-learn. It's like a
Okay.
science kit for learning, machine learning.
Okay.
So sklearn, but inside sklearn, if we visit their website, you see that we have many machine learning models, right? They are divided by topics. If they are classifiers, regressors, clustering, etc. So if I click, for example, on regression, we see hundreds of machine learning models. In our case, we want to import a specific one. So we won't import all of the models at the beginning. That's why we start with from sklearn. I get inside sub-library that if I want to use a decision tree, which is the keyword in decision tree? Tebian?
Decision tree.
Okay, but if you would have to tell me only one, Viva, which one would be? Decision or tree?
Tree.
So I write tree, and you see that we have the sub-library. Now, from that sub-library, I want to import the algorithm. And here you can see decision tree classifier, and regressor, right? Now, we want to calculate the change of tomorrow, which can be 1%, 2%, etc. Because it's a numerical number, we will use regressor instead of classifier. If we want to predict whether the stock will go up or down tomorrow, we would have used the classifier, okay? Which in our case, let's make it, okay, no, we'll use the decision tree regressor. Now, because this is a class, Tepian, do you know what we should do at the beginning with the class?
I'm not understand what are you saying. So you're not going to use the regular way of methods. You're going to use class.
Yeah, I mean, because you have a class, you need to first create the variable model.
DC or decision
That's
or
it.
tree. Yeah, equal كده.
And then
it.
that's it. In the model, you will have the functions to apply the mathematical operations of the algorithm, right? Because these codes, decision tree regressor, if I go at the very bottom, you see that it's in a folder within my computer, right? The file. If I want to check out the algorithm, I can open the folder. And you see here that I have the side packages, sklearn, and the tree.
Yes, sklearn. Then I have a subclass
Also,
which is
that's it.
tree.
That's why Viva before we had to specify the routes, the path to get to the tree submodule, because I have all of the Python libraries in this folder.
Okay.
If I get inside any of them, I need to select the one that I would like to work with. And you see that there are many types of machine learning models. Here we can see neural networks, we can see clustering, we can see decomposition, ensemble, etc. Also linear models here. And then inside each of these sub-libraries, we will have the codes that contains the step that the algorithm is running. So in our case, this class, decision tree regressor, if we go at the very bottom of the documentation, we can see that it's on the classes.py file. So if we go there, we can see that inside classes, I will open it with the Visual Studio. I want you to learn what goes inside the algorithm so that you know the steps to take. Class, decision tree regressor. You see that here we have the same help that we get in Python. In Python, if we do Shift Tab, it's the same. We have criterion. You can see it here. We later have the splitter that you can see here. So why are we seeing this documentation? Because it's written on the source codes that they developed. And now you see that inside the class, if we go down, we have the init, and then later we have the feed function. And if we see the feed and we go where it is, you see that first they check the inputs, then they see the parameters you put, if it was Poisson, etc. And here they start making the logic of the algorithm step by step. So this is what it's being run every time you calculate the mathematical equation of the decision tree model. And the best part is that you don't really need to know all of this. You just need to know what should you pass to the function, which is x and y, and they will run all of these steps for you and give you the result. Any doubts on this? Okay.
No, got it.
And this is what happens for most of the functions and libraries that you will use. It's always on a file in your computer. Now, Viva, how can we pass the x and y that they are asking inside the function, starting from this data set? What is the variable that we want to calculate? Is the change for tomorrow's price based on the close.
Okay.
So do we have the change for tomorrow in a column?
No, we don't.
So we need to calculate it.
Okay.
We go from here to here, and there is a change. We need to calculate that change in percentages. So we go to the close price, and then here we calculate the percentage change. If we pass this data to a new column, let's say tomorrow, change tomorrow. This is part of what we did the last day, so I will explain it a bit faster. We have the column here, change tomorrow, but this is minus 5%. In reality, this value should be here at this level, because having the information on this day, I want to know how will be the change for tomorrow. So I need to shift all of these values one cell up. To do so, I will use the function shift, but you see that shift by default moves the cells down one step. In our case, we will do -1, and now they are at the same level. And the last day, we won't have information. Therefore, we can drop the missing data, and now we are good to go. So now, Viva, how do I select the y variable, the change tomorrow, so that I can pass it to the fit function? You can dictate.
Oh, okay.
Have you ever wondered,
Parentheses.
okay, why parentheses, why brackets sometimes? Or the dots?
The square brackets we're just using to, okay.
Like
The
the square
square,
brackets, you go, sorry?
yeah, the square brackets is just to use the data in the column.
That's it. Is to access a part of the data, not to process it.
Okay.
If we want to process the data, we would look for a function that will
Okay.
transform it.
Yes. Okay.
So in our case, we just want the change tomorrow in the y variable, because there is only one column that we want to predict. And now for the x, we want all of the columns, but the change of tomorrow. That's why we will drop it from here. I can create a variable that will be target, and I will pass it in the drop. And now these codes, I will put it as x. Now that I have the feature selection for x and y, I can pass it to the x and y from the model. And now, because the mathematical equation will be calculated, this color will be blue. Okay. Now, let's say that first we need to see the data. Let's take the last day, -1. This is X today. And I would like to calculate what will happen tomorrow. So with the mathematical equation from the model, I will calculate the prediction for tomorrow. And this is what we get. That the stock of Apple based on today's price, on today's conditions, it will go down by 0.1%. So far, so good, right? Now the question is, how can we evaluate this mathematical equation in an investment strategy? Have you ever worked with the backtesting library? Debian or Viva?
No,
I
I
never.
haven't.
Okay, never, right? Also Viva, you don't. You haven't.
No, I haven't.
Okay. So how would you take and adapt this example to the code? I can copy paste this here. And now I need to adapt it. The first thing we need to understand from the backtesting library is that we need to create an investment strategy. And there are two main functions to develop the strategy. One is to define the initial data and artifacts for how you will predict what will happen tomorrow. And the next is the function that you will use every time to predict whether you buy or sell the stock. Okay. So, Viva, how would you adapt our code to incorporate the model? Where do you think you should put it? Init or self or next?
Could we please go again? I did not get what in it in next, please.
If I want to use the mathematical equation to calculate predictions and then decide whether to buy or sell the stock, where should I calculate the predictions? In the init function or in the in the next function? These questions of cold calling sometimes.
I think
Okay.
I
I'm
Because we
guessing
want
it's the
to,
next function.
that's it, because we want to use the predicts for tomorrow. So somehow I need to use this function here, right?
Yes.
Now, in the function next, I also need to select the data from today. So I would do it like this at the first step. Now, which conditions do we use to buy or sell the stock? Here. If you predict that the price of tomorrow, which is Y tomorrow, will be greater than 0,
Greater
it
than-
means that the stock will go up, right?
Yes.
So you would say, if Y tomorrow is greater than 0, we buy. And if Y tomorrow is lower than 0, we sell, right?
Yes.
Good. Now, these are properties of the backtest that they use as an example here. So I can use another name like ML strategy. And I can, by the moment, remove this. I can put here some pass. Good. Now we continue. Debian. First thing is that backtesting is not installed. We need to make sure we install the library. To do so, we can see pip install backtesting. Now that we have it installed, we won't get this error of module not found. So we execute. Now, even though we get a warning here, it's okay. We can still work with the library. It's a warning, not an error. So if we execute again, we don't see it. Now, Debian, how can we test this investment strategy? If you look at this example, this is the next function that they are using. Backtest. Can I execute it now?
Can you give me a hint or
Yeah,
something
I
to
think.
help me?
Sorry?
Can you give me a hint or something to help me
Okay.
to figure it out?
Let me execute. Also, I want you to, because I want you to think like a machine, I will tell it to you with the errors of the computer, right? Because sometimes we are a bit afraid of executing and getting an error, but that's not the best way to learn. I would say we learn more from mistakes than successes. So if we execute, we get here the first error, right? That Google is not defined. And that's because in their codes, they defined Google with this line. Let's check it out what Google is. So you see that it's a data set, right?
Yes.
But
And what is SMA?
in our problem,
Yes.
is this the data set we developed the machine learning model with?
Okay.
It is not. The data that we had used is
Not.
DF base, right? Or the X as well. Good?
Yes. Good.
So this is the data that we should pass to the model, to the backtest. We pass X. Now, if we execute, what is the following error? SMA cross, which in their codes is how they define the class, right?
Yes, I should replace it with ML strategy.
Awesome. There we go. Now, if I execute, we don't get any error. We are good to go. The following line of code is BT run. Let's see what it does. BT run is executing the backtest and the investment strategy. And here we see the results. So after making the investment, what is the final money that we have if we started with $10,000? Let me save this into a data, results, and now we will put the information.
To the frame.
Yeah. In a data frame so that we can spot it better. So which is the final equity? $0.13. Would you put your money with this investment strategy?
No.
So we better come up with a better solution. We can see that if we want to see the details of what's been the result of the investment strategy every day, we can use the function bt plots. If we execute, maybe I have to, that's strange. You see that we get an error like data contains too much candlestick to plot. That's because we have passed a lot of data. We have exhausting the resources of the library. So in our case, the full data that we pass to the backtest is X, right? Which contains data from the 80s. In our case, we may want to use it from the last 5 years. So we can get like n years, 5, and then n days will be n years multiplied by the number of days in a year. Now we select the data from this day with the minus until nowadays. So n days. There we go. So now that we have the data from 2016, we may get a better result. But also, yeah, it's been 5 years. Yes, because this is December. Okay, so now we save this back into the data. Yeah, that's okay. Let's run the investment strategy again. Let's check out the results. And now we get a different final equity, although we are still losing money. Let's check out for the plots that now, this is a warning, because there are some misconfigurations with the book library. Okay, fair enough. So, Viva, how can you interpret this data, this report? How many times have we buy the stock and then sell it? Out of the indicators you see on the screen, which one would you say? Is the number of trades.
Okay. 1, 2, 6, 4.
That's it. And you see that we have many triangles here, right?
Yes.
Each one of those triangles represents each one of the trades.
Okay.
If we zoom in on a specific period of time, you see how we are making the decisions, right? For example, we sold the stock here because we were predicting that it will go down, but it turned out it went up. So we are making a loss here of minus 1.014%.
Okay.
But there is also one problem, not one problem, but I want just to buy on the close. So there are some other properties like trade on close or exclusive orders that I want to be on true. And now let's zoom in again. Yeah, there we go. That is the thing as well, that is there any moment you think, Tebian, that we don't take a decision whether to buy or sell the stock?
I didn't think so.
Like, it seems that every day we are making a decision to buy or sell, right?
Yes, things like every day I should make a decision.
That's exhausting because we don't have to trade every day, right? We would like to
Yes.
trade if we are pretty sure about it. Why is the investment strategy investing every day? Because in the conditions, you see that it goes always greater than zero and below zero, any prediction, right? So if you want to be more confident, we will buy the stock if at least goes up by 10%. And we will sell the stock if it goes down by 10%. Good?
I think it's
Yes.
better.
Sorry?
I think this is going to be better, and
Yeah,
we're not going to trade every day.
that's it. Let's check it out with the plots. Well, it's not investing any day. Zero trades. Let's make another. But I think what's going on here, that's also one of the things that I wanted to discuss before. So why, given the conditions of the investment strategy that we have used so far, we take a decision whether the prediction of tomorrow is greater than 10% or below minus 10%. Let's check out how the predictions are being made every day for tomorrow. Let's execute. You see that we are predicting the same number every day. And that this number is not fulfilling any of these conditions. ¿Está bien?
Because our database is over مثلا fitted.
It's not that it's overfitted, it's that in the data, we are always passing the same day. You see that
Yes.
this is not changing. We are always passing the last day of the stock. There is one trick that you should understand from here, which is, you see that I pass a data set in the backtest, right? And the data set is inside the data parameter. Good?
Yes.
Now, the investment strategy that you see here in the next function will be limited to be the data from the starting date to the dates that you want to make the prediction. And for the following day, it will take the following day. It goes like step by step. To access it, instead of using directly the X, we need to use the self data. Okay? Self data will reference the information that will pass on any following day. And now we take the data frame to be y log minus 1. We name this like X today to calculate the prediction for tomorrow. We execute. And now you see that we get different predictions every day, right? ¿Está bien?
أيوة. But what is data? Excuse me, maybe I get lost here. What
Okay,
is
in
data?
this one, right?
Yeah, data. I think when I
Okay.
use it.
You need to see that this is a class that we are using from this other class, right? Strategy. Good.
Oh,
So this self class is a parameter that the function internally will treat to work with the backtest. And you see that this is the data parameter, right?
okay. Get it.
So to have the investment strategy work with these properties of selecting the data for each day, we need to access it through here, self data, and then we get the last day every time. Because if I make the print X today, you see that at the beginning, which day is it? The 16th of December, 2016, right?
Yes.
And then the following day, which one?
19.
Then the 20th, the 21st, etc. So the
So
difference here is that by using the self data property, the next function is advancing every day along with the simulation, with the data. But on the contrary, if we would have used just the X as we did before, which day is it taking? The last one, all the time.
Okay.
You see? That's why the prediction is always the same. Also, one thing that I see sometimes when we get deeper into the details, the session is being recorded, so don't worry if you don't understand a part of it. Like, don't let that misunderstanding continue with the lesson. One thing is to learn the logic of the thinking process, which is the one I want you to work with me during live sessions. And the other one is the coding, right? Which is the one you can work out later by watching the recording. So here, try to ask the doubts that you will face when you are on your own, and I will explain it here. But don't be trapped on just the code, okay? Good. So, more things. Now, if we run this backtest with the self data, we get different predictions. Therefore, the results should be different. Let's omit the print. And now, Viva, what do you see in this report?
Okay, we see that we've taken action only 4 times.
That's it. And we are not taking decisions every day, as we did before, right?
Yes.
Great. Also, what else can you interpret from this report? Until when we don't trade, we make a decision on the stock. This date, right? Which is 13th
March.
March 2020. If we zoom in, we can see that we were this low. The machine learning model predicted that the model would go up the following day
Yes.
by at least 10%. They decided to take an investment. They hold it until the model predicted that it would go down below minus 10%. And there we go. If we would have made a different approach, for example, not selling the stock until surpasses minus 50%, which is going to be impossible, do you think it will sell the stock at any point? Just
Ideally, no, it should
let's
not.
check it out. Unless the model predicts that it will go down by 50%, which is kind of impossible.
Yes.
Let's check it out. Well, it actually does. It actually does.
Okay.
If I, for example, take this prediction for tomorrow in the print, and we put the print only for the decisions to buy and sell, curiously, it's not getting any time inside this block. Let me print down. No.
Okay.
So, no, but this is a misconception that I might have. Like, because it's saying that it buys all the time. Yeah, no, I get it. So you see that here it's red because we are losing on this operation. We bought the stock, but since it went down,
So
we are,
relatively.
that's
Yes.
it. But then, because the model is predicting again that the stock will go up,
Oh.
it makes another buy. And from this buy operation, since the stock goes up, we close it here until we predict again that the stock will go up by higher than 10%, which I can even spot the dates if I do print X today name, I think. That's strange.
For greater than. Okay.
Yeah, it's on the up here.
Yeah.
Thank you. Yes, here we see that on these dates, the stock is being predicted to go above 10%, and that's why we buy and sell the stock. Okay, so which other things would you do here? Let me give you another insight or best practices. The way that you would use this data is by passing on the backtest the complete data set that you use, which is df base, but based on the last n days. And now we save it back into a variable, we would use it here, df. And then the model, the machine learning model, should be trained inside the strategy. How would you train the model inside the strategy? Viva? Where do you use the model fit? In the init or in the next?
Same case, we'll be using it in next.
Okay. Remember, the next is to make the decisions for what will happen tomorrow.
Okay.
In the next, you just make the prediction with the mathematical equation being fitted. Unless you want to train the machine learning model every time before making the prediction with the updated data, which you could do as well. But at the beginning, you would normally pass it to the init function. And to do so, you put it here, decision tree regressor, and then the model will fit X and Y. But now, how do we work with X and Y here? Remember, the data comes from self data. Therefore, you need to first take the X by having the drop columns change tomorrow, and then in the Y, self data df change tomorrow. X and Y, and then here we would need to access the data the same way, but also by dropping the column change tomorrow. Now, if we execute, let me take this out. We should get the same results. 1 second. Okay. We should get the same results, but let's check them out with the prints. Are we getting the same results? Viva?
Yes, the same result.
So it's the same code. Just know that this is a best practice to initialize the data that you have in the investment strategy inside the init and then performing the same logic in the next. Okay?
Okay.
Because now, if we want to select a different part of the data, the logic needs to go inside here. Now I want you to think another trick. You see that we have only used 0.1 and minus 0.5, right?
Yes.
But if I would like to try another thing, am I going to run this over and over again? Like now using 0.10, 0.2, 0.3, etc. And now am I going to repeat all of these codes on every time? Do you think is there a function that can automate this process? What would you say?
Maybe I need to check backtest parameter.
Okay, if we go to the bt.tab, you see that we have the function run, the one we used before, the plots, we also used it before, and optimize. And if I ask in the help, we have the maximize parameter, which is the one that we will use to tell which parameter from the investment strategy that we get from the results we want to optimize. In this case, to make it simple, I want to optimize the final equity. Now, there is another question. How can I pass the conditions to buy and sell the stock? I need to parametricize these two numbers. Do you know what does it mean? Viva, parametricize or parameterize.
No.
Is to create a variable instead of the value directly. So instead of having the 0.2,
Hard coding the value we store it in a variable.
that's it. We put, for example, limit buy, and then we need to initialize it. If you see in the example, the parameters that they are using, N1 and N2, they are being put right below the class. So this is where we use them. In our case, we will call it limit by, and then limit cell 0 minus 0.3. But in our case, let's put 0.3. Yeah, better. Now, if I want to try different options, looking at the help, do you know, Viva, how to look for examples in the documentation to see how you should use these two parameters? If you look at the documentation, where are the examples on how to use these parameters? If we go down below, we might see some examples.
Okay. Okay.
You see them here, right? And that's the parameters we put.
First and second. Yeah.
We need to put the values we want to try and see how it goes.
Okay.
So what should we put now in here? Optimize. What else?
So limit by and limit cell will be
That's it.
in second.
Limit by. Which ones would you put?
We can
You
try
will,
for 10%.
okay, 10%. What else? You can try as many as you want. Like, don't be afraid
Okay.
to put a bunch of them. Normally, you would put, for example, by 0.5 by 5% or by 1% every time. To do so, we can import the NumPy library. And then here we use a range that goes from 0 to 1, 0.1% every time. Good?
Okay.
So now we store this value in the, for example, thresholds or limits. And those are the ones that we would use in here. Limit by and limit cell limits. We execute. And it says that is the error says that is not defined because maybe we haven't executed this function again. So we execute again. I know where this error is. Have you ever faced this error, Viva or Tebian? You see, Tebian, that limit by is not defined?
Yes, because I think it's a local variable in the class.
That's it. Right now, we are referencing the variable as if it would be defined inside this function, but it is not. To this function, we are using the self parameter. And because we are putting these variables right below the class, the only way that we can access limit by and limit cell is by using the self parameter that we pass to the function. Good?
Okay. Yes.
So now we execute again, and we shouldn't get that error. We get type error and hashable type NumPy array. This can happen because the value should be on a list. If we see on the example from the optimize function, we see that they are in a pure list. This list doesn't contain anything like array whatsoever. So we need to pass limits to be a list. I know that is the same values, and sometimes it's strange having these errors, but that's how sometimes programming works. So let's execute again to see if everything is going well. And now it seems that the function is optimizing the best parameters.
So I just want to ask you a question.
Sure.
In place of making numpy then convert it into list, can we make
Yeah.
it a list from the beginning with a space of 0.1?
What do you mean?
In place of making numpy then convert it into list,
Okay.
we have this one thing.
Using range?
Yeah, using range.
Yeah, that would have been an option as well. Yeah. Sometimes like using this NumPy library, it's better for optimization. But yeah, I mean, at the end of the day, you can use whichever ones you would like. I think the optimize function is now taking a while. Let me stop it. Let's make it easy at the beginning. Let's use some random limits like 0.1 or 0.3. And see if the function will optimize. Okay. So now we will see the results. And here we get the best parameters. Which ones are they? Tebian? The best limit cell and limit by. I don't see we see it here, right?
I cannot see it here.
You see that we have the strategy here.
Oh, yes, strategy.
So we might need to get inside the strategy to see the best limits. And here we have them. But I don't see the results from each one of the simulations, right?
Yes.
Of combining these two options. To do so, we need to use the parameter return heat map equals true. And now in the heat map, once the backtest is finished, we can see in the results that we have two objects. First, the results of the best parameters, and then the combination of the limit by and limit cell. So we access the second, and now by using the function unstack with limit cell, we can put these values as columns. And here we can see the best results. To have a better comprehension, we can use the arrange from before by incrementing 20% every time, for example. Or let's make it from 0 to 0 0.5, 0.1%,
7. Okay. Can we try 0.7?
0.1 every time. Yeah. Should be okay. Yeah. Have you worked like this with backtesting before, Tebian?
I never work with backtest.
Okay.
itself, but we was making a function doing the same or familiar functionality
Yeah.
to back test.
Yeah,
I
but
think
the back test summarizes all of these operations nicely. Like it's the, to my opinion, is the most simple library for backtesting investment strategies.
it's cost
Viva,
effective. You can
sorry.
it's very cost effective. You can get your result easily, and the report is looking so nice and so
Yeah.
effective.
That's why I liked it. Although for strategy implementation would not be the best because I think it's a bit slow in a sense. But for checking historical strategies, etc., is really good. Yeah. So now that the result is performed, we can check it. And here we can see by using, for example, style background gradients, axis none, and then format precision 0. Wow. So if we put the limit at 0 to buy, we get this many, a lot of money. But this is false. Why is this false? Viva, would you think? This is a machine learning question. It seems that the model is getting what will happen tomorrow right every time. Like if we take a look at the report even, like there are a lot of green, as if the model was right very often.
Every time. Yeah. Looks like a case of overfitting.
Yeah, it's overfitting. And that's the thing, like to make this decision, we should split the data between train and test
Test, yes.
and then test it. To do so, we first would have imported from sklearn model selection, import, train test split, and then I run the train and test here with the data that was self data df. Let's use, for example, a test size of 0.2% because this is time series. I don't shuffle the data. And here I have now train and test that I will define it to the self on the test case because the test data is the only one that I will use to make decisions in the stock market. So here I need to use test. And now, but I think for the train and test, I might need to do something else. So have you understand it so far until here, Fabian?
I just confusing in one point. Are you
Where?
finished up, or you need to make more implementation on train and test? Because what I'm thinking about, and I should put X. I should not send all the data frame. I should split it first into Y and X, then
That's
split
it.
it then into X
That's
train
it.
and Y
But
train.
I am doing it here in this case. So in train now, X and Y. And then here I have the X today by dropping the change tomorrow so that I can make the prediction for tomorrow. Is that okay or?
I think I should have 4 parameter, or usually I should have 4 parameter. I cannot see these 4 parameters.
Which 4 parameters?
I don't need them.
Which parameters are you thinking?
X train, Y train, X test, Y
Ah,
test.
okay. I see it now. But you see that in the train test split, you see that you get arrays. You don't have here X and Y. And in the examples, if you pass X and Y, you will get the split like such. But in my case, I am only passing one array, which is df. So in my case, it's just splitting between train and test. I am not differentiating by X and Y here.
Okay, get it.
Good?
Good.
There are two ways of doing it. The most common one is the one you told me, but it's not the only one. So now if we execute this again, let's make the range. So now we get the results. And now the results are not that promising because I think we are losing all of the money, right? The final equity is 1% out of the 100 that we got at the beginning. It's like the model is predicting all of the cases wrong. And that's what normally happens when you have machine learning models. Like they are not a crystal ball that will predict what the market will say. We need to combine more parameters here or other machine learning models, like for example, random forest, other indicators in the data, etc. Like if you are more curious about this machine learning on investment strategies, you can check out the LinkedIn Learning course, which I think if you subscribe by the first time, you can get access for 1 month for free. And here I have step-by-step tutorials on explaining the full thing, if you're interested. So, leaving the promo to one side, which other doubts can we have from this backtest? Viva?
I have a question.
Sure.
So, are we training the model on the predicted value of the next day?
In
For the
this
day
case,
after that, are we
that's it.
considering the predicted value?
In this case, we are not. It's just first we train the data and then we calculate the prediction. But there is another thing we are not doing right because this data should be the self test. But sorry, I am here. Yeah, here it's okay. But there is one thing that I don't see yet. I don't see. So we are making investment decisions from 2016, but the data we are passing is DF, which is from 2016. Theoretically, if I am splitting the data between train and test, it shouldn't be making predictions from here until the test size from the 2%. So I think that the test, if I do print X today, is always taking the same data again and again. Yeah, you see? It's the
Yes.
19th of March. I think that's because of the property self data. It has to be on self data, yes or yes. I don't know if there was a tutorial from these websites that they explain backtesting.py, train test. Yeah, I think they have got one. Yeah, but they only use it here. So it's, in this case, we first need to have the data between n train, which is the number of days for training, and then if the length of the data is not above the length of the train, we won't get inside all of this code. So we need to refactor the code a little bit. First, I calculate the number of days and days. Now I calculate the number of days for training, which is the 20%. Let's use n. Well, n train should be, do you follow, Viva and Tebian?
Yes, yes.
Okay. So now, in this case, n train should be, I can remove the train test from here, and I just passed that the train will be self data ilog df ilog from the very beginning until n train. I drop the data, fit the mathematical equation. I should leave the data df here inside, and now it should be all right. We still lack to pass this function that we can do here. Yeah, I think we are now good to go. So let's use it and check it out. Yeah, you see that now we are advancing on the days, and we don't start from the year 2016. We start from the test set, which is 2022. Now, if we see the plots of the back test, we would see the investments on a different date. But first, I think we are not making any decisions yet because the limits to buy and sell the stock are very high. Let's use 0.5% and 5%. And here we can see that we don't take decisions until we are very advanced on the test set. And I think still we are making a profit a little bit, although there is a period that we go down by a lot. Doubts? Questions? Tebian? Viva?
Seems fine.
Good. So I hope that you have enjoyed a lot today's session. Remember that the step-by-step tutorial to learn how this library works is in our website. If you go to Datons.ai, you will see by searching here backtest, the tutorial where we explain everything step by step so that you don't get lost. Also some details that I didn't mention today, like the root mean squared error and why it's important to implement it in the backtest strategy, as you can see here, and how to interpret this chart we see at the beginning of at the end of the report. If you have further questions or you would like to learn how to apply this machine thinking methodology to any practical cases, remember that you can let me know in the Reddit channel and I will personally attend it. Also, if you want to suggest new live sessions or new tutorials, you can do so by creating a new post. And here you will tell that a suggestion and I will ask you more questions about it to see how it will fit and help you in your projects. And finally, stay updated with the content that we are promoting every day and every week by subscribing to the newsletter. And for the next week, we are hosting a new session. Make sure to check it out because it's also related to backtesting. It's Alpaca API. So far, we have learned how to work with the historical data and make investment decisions based on a historical data set. But now, in the next live session, I will teach you how to use the Alpaca API, which has the feature to let you a demo account to test investment strategies and see how they would perform in real life, but with a mock environment. Needless to say that this is not an investment advice, not whatsoever, disclaimer, but it's a very good practical case to learn programming and get deeper on how to work with different libraries, functions, etc. Further questions, let me know in the Reddit channel that you already know here. We keep on touch, and thanks Tevian and Viva for joining me today. It's been a really good pleasure.
Thanks a lot.
Thank you
We
so
learn a
much.
lot always.
Have a good one.
Have a good one. Bye-bye.